Hello, hi. Hello. Hi, guys. I guess I am a few girl talking about ZKP today, right? So my name is Mary. I am a co-founder of Orochi. We've been building Orochi for almost 3 years. And thank you, organizer, for having us today talking about ramen pasta, a new conditional folding scheme paper. And my problem solving is data correctness with the ZK database. All right, my topic, I try to pick the topic because I want you guys to observe the way we actually turning from the paper into application. All right, we have looking back a bit about the current state of ZKP in general. So initially ZKP is used to build up a verifiable computation. But then many people try to, scaling up the blockchain because blockchain developed quite rapidly, crazily. So we need a solution to scale up, and people working on many topics to, actually try to scale blockchain and or proving system. So some people working on zk rollup, and one of the biggest problem of zk rollup is proving times and parallelization. So in order to let zk rollup actually being practical, we need to solving the verification times and also the proof size. And also someone working on verification time and proof size. The thing with this is it needs to be optimized. Because if we want to zk be impractical, we need to optimize the verification time and the proof size too. And then someone working on verifiable computation to build up the ZK VMs or ZK CPU. But ZK VMs or ZK CPU itself is considered like kind of a gigantic circuit, and it causing a lot of difficult for development and the security as well. And then, in the market for now, people trying to build ZK VM, ZK CPU, and then for my team, we choose another approach by we solving the data correctness. Let me moving that. I guess everyone here is quite hungry, right? I'm just landing 30 minutes ago. And from one of the observation of my team from the ZKP state of the market, we developing ramen pasta. It's a new conditional folding scheme. For the first time, you can proving RAM program in parallel efficiently. And also, our conditional folding scheme in ramen pasta allowing you to folding non-complete binary tree. It's more efficient than folding the complete binary tree. Also, you can see that people try to solving the scalability of blockchain by many way, by vertical way, and then many paper also research had developed for that. But then if you, I think it's already written to the upper threshold of scaling by vertical. So our team, we're thinking to build up and to scaling the proving system by horizontal scaling side. So with ramen pasta, with our conditional folding scheme, actually we can allow you to folding with non-complete binary tree. We can allow you to proving RAM program in parallel, and this is the first time ever you can proving a parallelizable verifiable RAM program. Also with our conditional folding scheme, we allow you to build up the IVC, which means at the same time you have IVC, you have PVRAM. And also from those approach and from all of the characteristic of ramen pasta, we think that it's gonna be the very ideal solution for us in terms of solving another problem of verifiable computation is about data correctness. And let me, so next slide. So for what's happened with data correctness? Because normally the computational of data is just like garbage in, garbage out, and it's gonna be waste of time and effort if you just like keep solving the inaccurate input in the beginning. So that's why we're solving the data correctness by our ZK database. And first time ever, we're providing the provable data for Web3. All right, what do you think about on-chain data availability? This is a big question, right? And in order to answer that question, we looking back to the transformation of on-chain data and the provable data. So what happened with on-chain data? Normally at the moment still a lot of people using blockchain to store data, but blockchain itself is a synchronous system. It cannot solving a synchronous event like that. And also at the moment, people still like feeding the data from the smart contract to the app. And also, it's kind of familiar concept with our Web3 people. But for traditional people, for Web2 people, Oracle is still somehow unfamiliar. So we need another approach for people to actually interact with the Web3 database, which we call provable data and ZK database more efficient and easier. With provable data, we actually use blockchain to store the commitment, only the commitment. And we feeding data directly to smart contract with the ZKP instead of feeding everything on blockchain. And of course, the data can be fed with a ZKP. This is the concept. And we also have a comparison to see the advantage and disadvantage of on-chain data and provable data. So we can see that with on-chain data, the pros and the cons of on-chain data very obviously. So it's more expensive because the data have to be stored on-chain. And also it's slowly because it's required a couple transactions to get the data necessary, the necessary data. And also we cannot like eliminate the third-party trust. Why with the provable data, it's cheaper because the data stored off-chain is just commit with the ZK prover. And also it's faster because it just requires one single transaction to fit the data. And also we completely eliminate the third-party trust in provable data. Of course, going with the pros, also we have the cons. Compared to the on-chain data, on-chain data for now somehow is more familiar because the market already get educated. Somehow it's more familiar. Is it like this? Familiar to the concept of on-chain data, but for provable data, we might need some time to actually educate people how necessary of provable data. All right. So before that, let me, oh, no, not this. All right. I'm going to talk a bit more about the basic concept of ZK database, which means we build the first ever verifiable data pipeline. What it does? And for ZK database, simplify, we just query and update the data, feeding to from data and with ZKP from the app to the smart contract directly. And with the feeding is with the kind of commitment, we can use some commitment scheme like KKK to store the on-chain data and make sure that no one can kind of like insert or changing the data processing. All right, with let's see, we actually having some traction, 3,000 install of ZK database, meaning that actually it's very necessary and market fit for people. So inviting everyone, if you also want to exploring and having the same approach as solving the data correctness, you can come and talk to us and having using this. We allowing user actually like friendly only for developer. Managing the database and solving everything regarding provable data more easier. Okay, so what's provable data? I think Vitalik had come up with a concept of proof of everything. So in ZK database, we have the concept of proof of everything regarding data, right? The provable data meaning we do the data sampling correctly, to processing the data correctly, and to the lookup prover and transform the data correctly to also immutable in storage. And this is another kind of a basic concept of verifiable data pipeline. So the information in the real world information is the raw data, and we are going to make sure all of the process of the data is verified. By the way, we like, for example, with the verifiable sampling, that the data is going to be transformed to the construct data by verifiable sampling. And then from the construct data, we're gonna make sure that no one can change or insert or like having any inject into the data processing. And at the end, everything will be called verifiable data pipeline this way. All right, so we're talking about application of ZK database. Sorry. Um, this is some application of ZK database. Actually, we are providing provable data because I believe that in the near futures, when we're talking about data, it's not just data or raw data anymore. It's about provable data. And we can providing this kind of provable data for any ZKR for the app by the way we providing very friendly dashboard. And we also aiming to become the data availability layer for any blockchains, any smart contract platform. All right. Also another like application ZKML, verifiable private computation, and of course, our main purpose is we want to use the ZK database for high performance DApp and on-chain games which require like real-time interactive. All right, what's our next step? I think I talked a lot about application and our release product. And actually from this year, we planning to bring ZK database as a service for everyone to use it. And for now, you can totally visit our Orochi.network and download it and using that. With our ZK database, we actually can delegate in the proving. So the server side proving on high performance computer without sacrifice the decentralization, one of the very interesting characteristics of ZK database. All right, again, as a service for ZK database, and we're providing provable data for multiple platforms. More about our teams, actually my team with 20 people. My R&D team have 4 people. We are working on ramen pasta, the new folding, conditional folding scheme, which allows you to folding non-binary data. All right, and then we're gonna have, we also contribute for a lot of open source work like Microsoft Nova. You can check it here, and you can visit our GitHub to interact with us. And you know, if you are looking for some place to talk with, to chat, and also to contribute regarding what we have been doing here, we are welcome. All right, yeah, our slogan is just secure scaling Web3, and this is our Twitter. You can follow. Any question, please?
So we have 5 minutes Q&A time. Does anybody have question for Mary? Or for Orochi Network? Okay, thank you, Mary.